There was initially an infinitely dense mass of matter. This mass went through an explosion that led to the creation of molecules, atoms, and stars, galaxies that can be observed right now. This has been the reason provided by physicists for decades, but only recently a new idea has emerged from research, a perspective that suggests the universe has not as early an origin as was initially thought, but could be part of a recurring process in which the universe experiences a series of cycles of expansion and contraction, possibly in an infinite loop. Brian Cox, a well-known physicist, has also brought up disagreements regarding the Big Bang theory, stating that something cannot arise out of nothing. This interrogation adds a fascinating aspect to the discussion. Supplementary data from the James Webb Telescope has provided information that opposes the idea that the Big Bang marked the complete start of the universe. This leads to the fundamental question: if the Big Bang was not the beginning of the universe, then what was and what followed? Join us on this journey to the very beginning of the universe, where we'll explore the frontiers of the Big Bang and respond to this question and numerous others. If you want to keep up to date with universe news and its surroundings, please share this channel by clicking the like button to expand its audience and turn on the notification bell. Scientists have developed a thorough comprehension of the early stages of the universe, referred to as the Big Bang theory. According to this model, the universe was much less dense and hotter than it is now, circa 13.8 billion years ago. During that period, all the elements that make up our world were formed in a matter of minutes. Our universe, including stars and galaxies, was once as small as a peach and had an extremely high temperature of over a quadrillion degrees. This astonishing narrative aligns in accordance with all current observations made by astronomers, who have investigated everything from the remnant early electromagnetic radiation to the abundance of the smallest components of the universe, and have discovered that the predictions are correct in every way, to the best of our ability. However, despite its apparent robustness, we are aware that the Big Bang theory is missing something in the overall picture. The missing piece in this puzzle is an understanding of the first moments of the universe. This challenge is due largely to the restrictions of the physical theories we use right now, the combination of general relativity and the physics of high energy particles gives us an important conceptual framework. But as we go deeper into the very beginning of the universe, the level of mathematical difficulty rises significantly, getting to the point where our current methods are unable to provide meaningful solutions. One example of this problem is the existence of a point of singularity, infinite density at the beginning of the Big Bang, suggesting that the universe was once pushed together into an infinitely small and dense state. This seems absurd, and to deal with this challenge, we must investigate new frontiers in physics, develop approaches that overcome these limitations, and provide a deeper comprehension of the very beginning of our universe. Theoretical and current instrumental frameworks are not robust enough to address this challenge. So we need to create new physics that can include and describe gravity in addition to the other fundamental forces at very high energies. This is precisely where string theory comes in. String theory aims to be a real-world model capable of uniting the forces of gravity and the other fundamental forces, particularly at extremely high energies. Theoretically, it could provide an explanation for the very beginning of the universe. Within string theory arises the concept of an ekpyrotic universe, named after the Greek word meaning conflagration or fire. This idea suggests that the Big Bang in its current form was brought about by an earlier event, implying that it was not the true beginning, but rather a part of an ongoing process of expansion. The result of the ekpyrotic universe concept is the creation of a related theory known as cyclic cosmology, although the idea of a cyclic universe has been considered for millennia. String theory provides a solid mathematical foundation for it. In the context of cyclic cosmology, The universe functions as if it perpetually fluctuates between powerful explosions and collapses, a vicious cycle that extends indefinitely into the past and future. This cyclic cosmology theory was further developed by the eminent physicist Roger Penrose, who won the Nobel Prize. Penrose was intrigued by a remarkable mathematical relationship between the early universe, defined by extreme density, heat, and smallness during the Big Bang, and the future state of the universe, characterized as the extremely cold, expanded without matter according to the theory. These two states are mathematically transformed, identical when pushed to extreme limits. Even though it may appear contradictory, it's possible that the total absence of matter, the driving force behind the creation of all the stuff we see around us in the universe. From this vantage point, the Big Bang originates from the almost existent imperceptibly after the entire incident in black holes that eventually fill with photons scattered across a vast void. The universe originates from what? This viewpoint basically approaches. Despite the fact that this nothingness is still a form of something that constitutes a physical universe, albeit an empty one. The method by which the same state can be interpreted as both a dense universe and a cold, empty universe, depending on the point of view. The key to this comprehension is a complicated mathematical technique called a conformal transformation, a geometric transformation that changes the ability to retain the size of an object. Roger Penrose demonstrated that both the cold, empty, and the hot, dense states can be linked together by the scale transformation, aligning their spatio-temporal structures. Despite their variations in size, they may essentially be the same, despite having different sizes. However, Penrose argues that the concept of size loses its significance in light of these extreme physical circumstances in cyclic cosmology. A pattern of events emerges from an older, cold state to a young, hot one. The presence of the hot and dense state is the result of the previous cold and empty state. However, this causal relationship doesn't always go as planned in terms of the passage of time, as these extreme states include both time and size, losing their usual meanings. The cold, empty state and the hot, dense state exist on distinct timelines, which indicates that, from an observer's point of view within their own time frame, the cold, empty state would continue indefinitely. Philosophy and physics are intertwined in this domain of cyclic ideas. The study of the cosmos offers speculative and in-depth explanations of these cycles. Despite the fact that Penrose's cosmology lends credence to ideas, it advances a deeper philosophical question. Where did physical reality itself come from? How did these cycles come into existence? This leads us to ponder the reason for the existence of something as opposed to nothing, one of the fundamental metaphysical questions. For our discussion purposes, we will concentrate on the explanations in the realm of physics. There are three possibilities to think about when looking at the possible beginnings of these cycles. There is no tangible explanation for it. It could be an infinite series of cycles where each universe and the initial quantum state of each universe is determined in some way by some aspect of the universe that preceded it. Finally, there is the option of both a single cycle and a series of deities, as universes in which the initial cycle is explained by some feature of its own end. These possibilities are attractive because they do not require uncaused events and provide more complex physical explanations in the field of physics. Penrose proposes the idea of an endless cycle sequence influenced by his application of quantum mechanics in the physical system. Quantum mechanics exists in multiple states simultaneously until it is discovered, after which it randomly collapses into a single state. According to Penrose, each cycle is affected by erratic quantum events that cause differences between cycles. This idea offers promising possibilities for experimental physicists, as it suggests the possibility of picking up on minute traces or anomalies in the radiation that remains from the Big Bang. What do you think? Let us know in the comments section. If you enjoyed this, take a moment to like the video, subscribe to the channel, and share this video to expand its audience. Characterized as extremely cold and expanded without matter, these two states, according to the theory, are mathematically identical when pushed to their extreme limits. Although it may seem contradictory, the complete absence of matter could be the driving force behind the creation of all the matter we observe in the universe. From this perspective, the Big Bang emerges from an almost non-existent state, imperceptible after black holes consume the universe, leaving photons scattered across a vast void. So, what does the universe originate from? This viewpoint suggests that, despite being nothingness, this state is still a form of something, a physical universe, albeit an empty one. The key to understanding this lies in interpreting the same state as both a dense universe and a cold, empty one, depending on the perspective. This understanding hinges on a complex mathematical technique called conformal transformation, a geometric process that preserves an object's size. Roger Penrose demonstrated that the cold, empty state and the hot, dense state can be linked through scale transformation, aligning their spatiotemporal structures. Despite differences in size, they are essentially the same. However, Penrose argues that the concept of size becomes meaningless under these extreme physical conditions in cyclic cosmology. A pattern emerges in cyclic cosmology, transitioning from an older, cold state to a younger, hot one. The hot, dense state results from the previous cold, empty state. Yet, this causal relationship doesn't always follow a predictable pattern in terms of time, as these extreme states cause both time and size to lose their conventional meanings. The cold, empty state and the hot, dense state exist on separate timelines, suggesting that, from an observer's perspective, within their own time frame, the cold, empty state could persist indefinitely. Philosophy and physics intertwine in this realm of cyclic ideas. The study of the cosmos provides speculative yet profound explanations for these cycles, while Penrose's cosmology lends credibility to these ideas. It raises a deeper philosophical question. Where does physical reality itself originate? How did these cycles begin? This prompts us to consider why there is something rather than nothing. Oh, as if nothing rather than nothing, as fundamental metaphysical question. For this discussion, we focus on physical explanations. Three possibilities arise when considering the origins of these cycles. First, there may be no tangible explanation. Second, there could be an infinite series of cycles, where each universe's initial quantum state is shaped by aspects of the preceding universe. Third, a single cycle or series of universes might exist, where the initial cycle is explained by features of its own end. These possibilities are compelling because they avoid uncaused events and offer complex physical explanations. Penrose proposes an endless sequence of cycles influenced by quantum mechanics, where systems exist in multiple states simultaneously until observed, collapsing into a single state. According to Penrose, each cycle is shaped by unpredictable quantum events leading to variations between cycles. This concept opens exciting possibilities for experimental physicists, suggesting they might detect minute traces or anomalies in the cosmic microwave background radiation from the Big Bang. What are your thoughts? Share them in the comments below. If you enjoyed this, please like the video, subscribe to the channel, and share it to reach a wider audience.